Welcome back. Happy Friday. And for some, probably happy Saturday. Alrighty. Today, we're finally back to NIM language after last 2 days where I kind of went off the rails. And I figured instead of dealing with Common FS again, we're gonna continue with our terminal app for showing a countdown timer. And we'll just continue with what I started doing last time, which is totally revamping rendering into some kind of buffer-based gaming engine. And we'll see what happens. So, as per usual, feel free to like, feel free to subscribe. I welcome all the comments, even after the stream has been, finished. I like to engage. And yeah, if you're watching on Twitch, you can follow and all that good stuff. So, as per usual, we can start with a little bit more of NIM tutorial, just to keep our skills up to date. And where did we finish last time? We went through array statement and through try, right? I think we went through that, right? I think so. Yeah, the next thing will be generics, which is the fun part, and then templates, and yeah, we'll be done with second tutorial. Then we'll be able to look at macros and get a headache, so that's exciting. So let's see, generics. Generics are NIM's means to parameterize procs, iterators of or types with type parameters. Generic parameters are written within square brackets, for example, foo of type T. They are most useful for efficient type safe containers. Okay. So we'll define a type, which will be a binary tree of type T, and it's a reference object. So binary tree is a generic type with generic param T. Left and right subtrees may be nil. Okay, so we have left and right, and it will be of type binary tree, but because it's a reference object, that means it can be empty. It can be an empty pointer, which will be just nil. And data of type T. Depending what the type T is, it could be empty, could be not empty. It totally depends on type T. So that we the data stored in a node. So then we define new node, and that proc is also generic of type T, that we can provide the data of type T, and that will produce the binary of type T. So classic generics. A constructor for a node, new result. What the hell is that? That should be like result, right? Well, what is new and wrapping the existing result? Okay, that's new. I have no clue what that does. That's strange. What the heck? And then we do result.data is data. And we don't even... What's the point of that then? Because we should already have a new result created, I guess, unless it's nil initially. Oh, I see, because it's a reference type. That means the result is empty initially. And this kind of thing where you give it a variable, this creates a new instance of that and assigns it to result. Okay, that's the thing we learned previously a little bit. This is like totally confusing, but I guess it works here. Okay, so it's like a var ref binary ref object, var ref object, yeah. A variable to a reference, so it replaces the reference. Cool. And then we can specify the result.data is data that we passed in here, and that's it. Creates a new binary tree. That is kind of cool. Then we have proc add. That's also generic on type T. It takes the binary tree T, but binary tree is a ref object, so this is a variable reference object, and then another binary tree. And what it does, if the root is nil, it's just we assign the second one because we're adding binary tree to an empty one, just replaces it. So this is where we have the thing that we have this root, which is a reference to an object, and we replace the reference. And if it's not empty, compare the data items. We did a whole tree thing where we compare stuff and do tree stuff. Okay, cool. We have another add that we can add just a simple element. Okay, so we just take the root and we just create a new node with that. So this is, yeah, this is very simple. Okay, makes sense. And then we have iterator, preorder traversal of a binary tree. This uses an explicit stack, which is more efficient than a recursive iterator factory. Oh. We have stack, which is a sequence of binary trees. And we just create one of them. And while we have something left, we do stack pop, we grab it, and yield the data and pop. Oh, okay. Oh, interesting. So it basically operates on a sequence of stacks rather than, so this is, wait, were sequences defined on a heap or on a stack? That's a good question, because now I'm starting to get confused. I mean, they should be on a heap because, yeah, they can grow. But I guess we're just not doing this whole thing where we're getting back and forth and passing them around. It's all within one thing. Okay. Just more efficient than recursive iterator, because I guess every time we do some recursive stuff, whenever we go into another proc, which will be equivalent of a C function, suddenly we need to have all the tracking stuff, like, you know, which, you know, a bunch of stuff needs to be written to the stack or whatever to just keep track of the spot we are and where to get back with execution and all this stuff. There's probably some call stack tracing there and other stuff. So yeah, this would be this could skip all that. So that's interesting that they're showing that here. Cool. And at the end, we can just create a variable of binary tree, and we specify it as a binary tree of strings. Okay. And therefore, we can just use those strings everywhere and just have things working. The example shows a generic binary tree. Depending on the context, the brackets are used either to introduce type parameters or to instantiate a generic proc, iterator, or type. As the example shows, generics work with overloading. The best match of add is used. The built-in add procedure for sequences is not hidden and is used in the preorder iterator. Yep. There's a special colon T syntax when using generics with the method call syntax. Oh. So we can just define that we're defining a proc foo on type T where we can call it on anything of type T, and we just do discard. That will just, hide everything? Then we have variable I of type int. So I.foo of type int, error, expression foo I has no type or is ambiguous. Oh, interesting. What the heck? So you can just make, so this will be a proc that can be called on pretty much any type. Literally anything. That's cool. That is very cool. You can define it on pretty much anything. And then probably within the proc, you can just do different, in cases this, in cases that. For everything else, do whatever. Very curious. But then we just need to, excuse me, we need to specify that. But do we even need that in the first place? Can we just skip this whole thing? Shouldn't it be inferred from that? Let's try that. Because it would suck if inference didn't work there. Let me just get to the stuff. So let's open recent and we can go back to the come on a fast temporarily, because that's where we have the little thing for running code pre-made. Okay, so let's paste that in. And this seems to work, right? Now let's do echo the type of I is, and I just do T. Will it print out T? I never tried that one. Yeah, it prints the type of T as int. So what if I'll make it float 64, okay? I save it and it's unhappy. Can I just cut the whole thing and save it? Yeah, it should work, right? It recognizes it's float 64. So we don't even need any, qualifier. It's just if I would do float 64, I guess it's unhappy because of this thing that makes it work for everything. So either you do this whole thing to signify that it's for self, or you just skip the whole thing, which is even nicer. Yeah. Oh, this is fun. Okay. It's cool that we can discover something that works everywhere. But what if we have also another proc that's full of, and not even generic type, is I is float 64. And it will just say echo I'm so floaty. Okay, when we run it, I expect that the generic one will be less specific than the non-generic one, therefore Nim will probably choose to run this one. That's my expectation. Yep, I'm so floaty, that wins. Okay, but that still means that we can do whatever, a number.foo, and that will just print out that it's an int. Because both exist. Yeah, there we go. And this is crazy. You can just do ha 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 ha. And it will work. There we go. String. Huh. Yeah, I like that. It's very interesting. And echo, of course, works that way too, right? Because echo just doesn't care. Yep. Huh. Fun. Okay, we learned something, so that's fun. Cool. And now something even more fun. Something that I know that I'll be using more and more as I'm getting more comfortable with Nim. So templates. Templates are a simple substitution mechanism that operates on Nim's abstract syntax trees. Templates are processed in the semantic paths of the compiler. They integrate well with the rest of the language and share none of C's preprocessor macros flaws. To invoke a template, call it like a procedure. For example, we define a template, which will be not equals, so it's an operator. Okay, that already opens up so many possibilities. That takes A and B, which is untyped, and returns untyped. This definition exists in the system module. Oh, so this is just an example of not equals, which I presume would just replace whatever we just wrote with not A equals B. Because if we have equals defined, we can just rewrite the whole thing for not equals. Cool. And we can just run it, and is that being a template just replaces it. So that's cool. Yeah, so this way you could just straight up replace stuff, extend them, whatever, repeat without actually running stuff in the during runtime. You just change up the code. So that's cool. I wonder if one could, like, there's this new language that was released, band language. Here is Band is a massively parallel high-level programming language that you can basically write this or whatever, and this is a little bit more interesting, where you can basically write your code normally. You just don't use loops. You have different constructs for that, and it will automatically parallelize your whole code to run on all the cores of your processor, or straight up just run it on your graphics card on CUDA, which is mind-blowing. Yeah, it does some fancy logic behind the scenes, where like turns stuff into the graph or whatever. I don't think it's being explained here. But I wonder if maybe not to that extent, but a little bit. Could be, wait, not here. Could be done with nym template and macros just to, yeah, abstract some things. So yeah, that's cool. So the not equals, larger than or equal, in, not in, is not operators are in fact templates. This has the benefit that if you overload the equals operator, the not equals operator is available automatically and does the right thing. Yeah, it just replaces the code. Except for IEEE, floating point numbers. Not a number breaks. Excuse me. Not a number breaks basic Boolean logic. I guess, yeah. And then you could probably make it so that there's a specialized not equals for float. And because it has this type float specified, it's a little bit more specific than a template with a very generic untyped, and therefore the compiler would choose that. Okay. A is larger than B is transformed into B is smaller than A. A in B is transformed into contains B A. Not in and is not have the obvious meanings. Okay. Templates are especially useful for lazy evaluation purposes. Consider a simple proc for logging. Okay, so we have constant debug is true. So we define a proc log message string, and we say it's inline, of course. So if debug, right, standard out write line message, and yeah, and we do that. So this would basically, we have that variable here, whatever constant. And what would happen here is that first we're actually running this, checking if it's debug during runtime, and then writing it, right? And of course we need to have this whole string already provided here, which means we need to calculate it and all this stuff. Yeah. So yeah, when we call this, we already concatenated the string and everything, so it's doing the work. All right, some microscopic flies fly. So next, this code has a shortcoming. If debug is set to false someday, the quite expensive, toString and concatenation operations are still performed. The argument evaluation for procedures is eager. Turning the log proc into a template solves this problem. So we have a template that takes a message string and basically does if debug, do this. How does it solve it? Because we have the same code, right? The parameters types can be ordinary types for the meta types, or the meta types, untyped, typed, or type. Type suggests that only a type symbol may be given as an argument. And untyped means symbol lookups and type resolution is not performed before the expression is passed to the template. If the template has no explicit return type, void is used for consistency. So how does this actually make it more performant? Because it kind of replaces it. Oh, I see. Oh, okay. So basically, I will probably do it even a little bit better. Oh no, because this depends on... okay, I see. So if I'll just grab this code to simulate what happens is that we have this thing, right? So when we call log, what happens is this whole call will be replaced with this message thing. And I presume that we just grab whatever was in here, right? And whatever was passed here, we are not evaluating it here yet. We just know that it's a type of string. And that's all we need to know. We don't need to calculate it yet. We know that, when the compiler is analyzing it, it figures out that, hey. So we just grab that. We just paste it in here and remove that. And this is our end result. Okay? So this is the code that it will actually be compiling. And because of that, this won't be running unless this is true. And additionally, if you knew that debug is either true or false, and you have a situation like here where you never, when you compile a program, you either have it set to on, or set it to true or false, and you don't have a situation where you pass in some extra argument, you could probably just do when debug. So it would just replace it with when, and if debug is false, this whole line doesn't even exist, which is even nicer. So yeah, that's fun. So it's good to know that the argument excuse me. Ooh. Need some water. So it's good to know that this is not being evaluated right here yet. This is just being passed in and is being evaluated, in the resulting codes. This is very, very, very good. I like it. I like it a lot. The parameters types can be ordinary types. Oh yeah, we're reading that. And the type suggests only a type symbol may be given. So we just know what types we're dealing with. If the template has no explicit return type, void is used for consistency with procs and methods. Okay. To pass a block of statements to a template, use untyped for the last parameter. Okay. So this is the example that I really like. We define a template with file. We give it f, which is untyped, so we give it some f. We give it a file name, okay? We give it mode for file mode. And the last argument is body, which is untyped, okay? And what a equals to is, and we have this code. So this will be basically copied and pasted whenever we have the execution of that. So we just define that there will be let file. So we define a variable with the value of the file name. So that's a string. We do var f is file. So wait, we provided f, and we define another f. Okay, I guess this just means that we can call it on the f, but it's untyped, so that's interesting. And then we open that file f and function and mode, all that stuff. And what we do here is we try body. We just put this whole thing here. If we just say body, so this code that we pasted here is just going to be placed here. And then we have finally, which closes the file. Excuse me again. And yeah, if it worked to open the file, we just print out that, exit the app. So suddenly this thing will just be transformed. So if we have code like this, when compiling, this whole thing will be transformed into this code. We just grab a file name, which will be copy pasted here. Okay. F file, I don't understand that part, so I don't know what happens to the txt. What is this? I don't know, we just assume that F is a file or something? I really don't understand that part. And then F, which should be this really, but this is confusing me. Fn. Mode was here. What was Fn? Oh, just the file name. So, oh yeah, Fn is from here. Yeah. Yeah. So we have all that. Try the body goes here, which is those two lines are just being placed in here. Close F and cannot open Fn. Yeah, so this will be transformed into that. I just don't get that part. What's the thing with the file? In the example, the two write line statements are bound to the body parameter. The write with file template contains boilerplate code and helps to avoid a common bug to forget to close the file. Note how the let fn is file name statement ensures that the file name is evaluated only once. Oh, that's smart. Yeah, because if we were using the file name everywhere, whatever code was here, if somebody instead of would put the whole evaluation here, like add this and do this and that and that and that, I mean here, if they put it here, this whole evaluation will be copied here and in the other spot and then in the other spot. In this case, it will be in here and then again in here. And this way we just do it once. But still, what the hell is this? We just changed the definition of this thing? Too bad they don't explain that part. So let me just copy the same thing again and see what happens. Because this is happy, right? What if I'm going to remove this? Now it's unhappy. So just transfer this is F. And now it's unhappy because undeclared identifier txt. Oh, wait a moment. I see. Wait, the whole thing. Oh, this is so weird. So in our template, we define that there's something, because before that, there's no mention of txt. Okay? We just have f, which is untyped. Well, here we are reassigning it. Oh. So we don't care what's in here, right? We totally don't care. We just know that it's an F. So whatever code we passed here, whatever thing that looks like code we passed here, is just gonna be the F. The code will be used here, I presume. Okay. Therefore, we can just say that way. I'll call it txt. And therefore, I can use it. Oh, this is so mind-bending. Huh. We can introduce just a name, just a whatever. And just use it like that. Very interesting. I like it. That's cool. So I could do F1, comma F2 untyped, right? And I could straight up make F1 to be a file and F2 to be a file. And basically do and. Oh, I shouldn't do that. I should do for this one to run something. And then I could do the second for the second one. F2. Right? We have F1 and F2. So run the same code for two of them. So that would be F2, F1. And that's it. So we could do txt1 and txt2, where we define them to. But when we do that, it should freak out or not. Oh, but execution will freak out because the way this will be done is that it's gonna take this whole thing, right? And this will be replaced. Let's just manually replace it. File name will be just replaced with this. Okay. F1 will be replaced and all the spots with txt1. F2 will be replaced with txt2. And mode will be replaced with this guy. That's all the replacements that we needed. And then the body will be basically those two things. So we just have, whoops, we just have this. And here's another body, so it's gonna place it again. So this thing will suddenly produce this whole block of code. Okay, with just not indented like this. So we're defined as two variables, those two files, that's fine. Then we open the first one, and this is gonna run. This one will try to run, but the file will be closed because we haven't opened it yet and will fail. If for some reason this would be okay, this one will fail again, and therefore this one would fail because it was already closed. Very interesting that you can just generate code just like that. Yeah. Okay, I like it. You can do fancy stuff with it. So we just learned about that, and we have one more example of templates for lifting procs. So let's see what we have here. We import math, and we have lift scalar proc fname. And this doesn't have any type specified. Okay. Lift a proc taking one scalar parameter and returning a scalar value. As in proc for 5s's of type t that takes an x returns a float. Okay. To provide template procs, you can handle a single parameter of sequence t or nested or the same type. So let's see. We have the template, and the template just defines a. Oh, what? Defines. But why doesn't it have define any type? So this basically will define the function name of type t that takes an array, or no, open array of type t and returns whatever it will infer. So we create a temporary variable for the t. Out type is that whatever comes out will be type of the f name that takes the temp. Oh, okay. Okay, so I guess we're switching a function that was taking a single element to a function that takes multiple elements. Okay, so we basically needed to pass in, what the heck? Something that takes single element. Oh, and the result will be a new sequence of those functions and that many elements as we have elements in the array. And then for each of those elements, we just call it. Which one this refers to? I don't think this one. Or this one. How the hell do we... This is confusing as heck. Lift scalar proc. And we do square root. Echo square root. And all those. And we'll just return those values. Huh. Why doesn't this have anything specified? It's not untyped or anything. So I don't understand this suddenly not being here. It's something new. I'll be right back. And I'm back. Okay, so we went through templates, and that's something that I guess we'll need to read the manual to understand properly, because I really don't know why this doesn't have type. And we have last little mini chapter about compilation to JavaScript, because that's true. NIM can compile not only to the C language and C++, but also to JavaScript, which is just like a vast, gigantic difference. And apparently a lot of people use NIM for front-end code, because why not? So NIM code can be compiled to JavaScript. However, in order to write JavaScript compatible code, you should remember the following. Address and pointer have slightly different semantics, meaning in JavaScript. So yeah, if you're doing address and pointer stuff, don't expect them to work the same. It is recommended to avoid those if you're not sure how they are translated to JavaScript. Cast x to t, and JavaScript is translated to just x, the same thing that already is. So it's being ignored. Except for casting between signed and unsigned integers. in which case it behaves as static cast in C language. And then the C string in JavaScript means JavaScript string. It's a good practice to use C string only when it's semantically appropriate. For example, don't use C string as a binary data buffer. Okay. Not bad. That could be something to play with at some point. So next stream, maybe Monday or Wednesday, depending on when we'll touch on the actual NIM. We're gonna go through macros, which will be painful, but we're gonna get through it, and we'll have all the tutorials basically checked off on the live streams. Okay, cool. So let's get back into our coding. Let me just grab and switch to our stream utils to the countdown and see where we finished. Ah, okay, I remember. Why does it show errors? Color. Can I evaluate? Let's try to run it. Yeah, let's save it. Let me just get our trusty terminal up and running. It'll make sure that it still is running properly. Okay, that is still running properly, so that's good. So seeing this instantly tells me, like, on the stream it's hard to see, but basically when we specify where the background is black, it actually got black, which is different than the regular color in the terminal. So I think there's a difference between background color that is specified and background color that is not specified. As in, the specified one is exactly what we specified, while the unspecified one is like transparent, where it is whatever your terminal settings are designed to, which is, again, I presume some people have, like backgrounds that are images for the terminal, whatever. So that would be probably the color of the terminal. So that's one thing that we need to handle, the lack of specified background color. Then I presume another thing is the lack of foreground color specified. And then the lack of style specified. So it's like we have either no style, no color, or no colors. We need to basically handle those empty values. So that would be one thing to take care of. And that means a little bit more trying to figure it out. Where do I even start? But basically this code runs, so that's what makes me happy. So far we had just the string for foreground color, for background color, and so let me just quickly explain it overall from the distance how this thing is working, so that I have it in my head and I'm thinking clearly. So basically, for when we start our terminal app, we're using this terminal.nym, which basically calculates gets the size of the current terminal, and based on that, it creates a new buffer of basically terminal pixels, whatever. Whenever we can place a character, there could be character, no character. So all those columns and lines. And here in our buffer, for now I call them pixels. I think I'm gonna change it to something else, like maybe a cell or something, because pixel is kind of misleading. And then what can we contain in each of those cells or pixels or whatever? Of course, we can hold our Unicode rune. We can't have it ANSI because multiple ANSI characters can make one rune. So we need to operate on ASCII runes. So that's the first thing. And then each of them can hold foreground color, background color, and style. And for now, I basically had pre-calculated a string for the characters that define the color, for the foreground, and for the background. And I guess that's fine, because if I will set it to an empty string, it will just not change the color, which is nice. But at the same time, we need to remember if the previous character that we printed out was of some other color. If yes, we need to reset it and reset things. So we kind of need to manage those things. And then we have style, which should also accept no style. So that's another thing. So maybe that could be held as a string as well. And we just have those three things, and we can keep remembering what was the previous character we printed, if we need to update any of those values, and so on. So yeah, that's what I'm thinking about right now. And then we have the decision. Do we want to hold just a color, which will be just an integer, or do we actually want to have those strings pre-calculated? Let's run some numbers, okay? So just here as a comment, we'll just think, or maybe, hey, if we're already doing code, so we might as well go here, and yeah, printing here won't be fun because we cleared the whole screen. So basically what we could do is calculate the size of a pixel. What would that be? So I would like to know what the pixel actually holds when we set it. So let's do something like this, because here we import the terminal, but we don't import the buffer. So let's import buffer. Import buffer, okay. So that we have that thing, and with that we can do a few things. We'll create our pixel. Do we have like initializer for pixel? No. And that will be basically pixel, and we specify it as empty. Everything's empty, okay? The default state. Then we have in the terminal something like set foreground color and all that stuff. So we were using this ANSI background color code to get a color. So let's do something similar. Let's just comment out this terminal. Let's comment out all the other code that we have in existence, because I'm trying to figure out how we can actually test it now. So this was trying to import our terminal, but we don't want to use that temporarily. We want to be able to use the normal standard terminal. So import standard terminal. And from there, we have this ANSI background color returns a string. So let bg color is, and we just give it color. We need to import colors. Not this colors. We'll import standard colors. I think that's the thing again. Or just color. Let's import. Okay. Colors. And we just grab some random color, right? So I want to echo size of. So the color string size will be the size of bg color, okay? So this should print out how many bytes our color uses. And I hope it includes the actual values, not just the size of the pointer. So that's that part. And then, yeah, and then style. We'll get to that. And then let's do echo emoji size. And we'll just do some kind of emoji here. Let's do the family, right? Because that's like multiple things as far as I know. And what happens when we run it? Of course, I clicked off the terminal. Wait, what the hell's going on? So, color string is 16 characters, 16 bytes. How is that possible? And then emoji size is 16. What if I'm gonna combine like 3 of those? Is it still the same thing? Without indentation. Oh wait, what the hell did happen here? Okay. Still, so this is just a pointer to string. How do I so that's 16. And then we need to on top of that, so let's do var string size is size of the BG color. Okay. And we're gonna print that out. But we also need to calculate the size of each character. So what we could do here is basically do string size, increase it by size of, and we take the BG color, the first element, okay? And we do this times BG color length, okay? And then we can print it out. And we'll just do bytes, okay? And do the same thing here. But emoji size, again, we have the same thing. Okay, helper function. Proc calc size, and we have s, which will be var string, or no, just the string, right? And we'll get an integer. So we do result is the size of s, and then we need to do this whole thing here again, which will be result bus equals this, and therefore s. Okay, we'll assume that the thing has at least one character for now, and that's it. Okay, sure. If len of s is larger than 0, then we just add it. Okay. If not, we're not. There we go. And no parentheses. s.len. Okay. That's better. So we can do string size, whatever. Let's do color string size is bg color dot calc size. Okay. And this one will be this calc size. Save and run it. There we go. The string for the color is 67 bytes, while emoji is 41. Okay, 67 and 41. So let's imagine, first of all, We don't need that many. Okay. And let's see the difference. 33 bytes while this whole emoji got to 41. So let's say that somebody went crazy and just printed out a million of those emojis, like on everything. We're looking for the worst case scenario. I want to calculate how much memory can the buffer use. So, yeah, so let's do let color size is this, and let rune size is this. And we just printed those out. And now let's calculate the actual thing. So constant columns and stuff, I can just get that, right? So how did I get it? That was in the terminal. I had it somewhere here. Terminal size. Oh yeah, terminal size. That's what we can get. And let's do that. The let terminal size is this. So let's do size X, size Y is this. Okay, so we should have both integers of X and Y, because that's what it returns, presume. And therefore we can print it out. That's the terminal size. Let cells count to that, and we'll print it out. And then we basically do is back. Okay, I am back. Awesome. Good. Hello, drunk alcoholic. I can see you wrote something. Hi, I'm Diesel. Just dropping in for 5, but we'll be back later to watch the rest of your. If I'm still streaming. Yep, I'll be probably for extra 1, 2, or 3 hours or something. So you're welcome back, of course. Yeah, I'm trying to calculate the worst possible size of the buffer on the screen. So each cell will be basically 3 instances of the color and the rune. So we just do let, and we do max cell size. It's done in bytes, and total size will be this. And we'll just do that many kilobytes. Sure. So let's run and see what happens. So that many. Terminal size right now is 157 by 36. Okay. Total cells, that many. 140 bytes per cell. That means we have 772 kilobytes of RAM used just to display this terminal here. What if I'm going to make it to something smaller and rerun it? Something that somebody might be actually running from time to time. Okay, now we get 504 by 110. And that means 7.5 megabytes. Oh, geez, that is not optimal. That is definitely not optimal. So, yeah. So let's add to the calculations. Variant if our pixel is smaller. Okay. So let's say I'm not even using that pixel. We don't need that thing here. So let's recalculate it now for in case we have a color and style specified here, okay? So, let me think. We'll do, we're at C size will be for color, okay. Size of color, okay. And then we have rune size stays the same because we need to still assume that somebody will be shoving in worst emojis possible. What's next? Next we have the same calculations here. So let cells caliber we use, cell size, let new cell size is C size, this, all that. Oh, now we also need to let S size of style. What is color and what is style? Do I have definitions somewhere here? Of course not. It won't show me, unfortunately. And new cell size is that much. New total size is this. New total size. So let's do total size for strings. And total size for native. Okay. And let's see what happens. Okay, in this case it was less. And then we have, we can run it again, but just for when it's really small. And the difference is roughly the same. Okay. Okay, but still from 12 megs to 6, that's better. Yeah, that suddenly wants me to store information a little bit differently. But let's assume that for most characters, we have a simple emoji, not something complicated, right? I heard a Twitch sound. What happened? Hexadecimal universe. Okay. Very interesting spelling for hexadecimal. Hexadecimal universe as followed. Hello to you too. For you it's good morning. For me it's 11 p.m. So for you it'll be 23. And you're from Germany. Also, hello to Germany from Georgia, US. How are you doing today? Wow, it must be really early there. Holy moly, you get up early. Wow. How do you do that? Okay, so let's run a scenario where maybe we have a simpler emoji, not the crazy one, just a simple smile, okay? Simplest emoji possible. Maybe that will make a difference. Oh wow, holy moly. Oh no. Okay. So let's rerun it with the family thing. Because I'm starting to doubt what the hell's going on. Okay, so with the family emoji, we had like with a better situation, 539 kilobytes. Here we have 364 kilobytes. What if we have just normal characters like what would that be? A. And not that much of a difference. 364, 340. How is that the only difference? Very interesting. Doesn't make any sense. But oh well. Great. Okay, so I guess if we would, instead of holding those pre-compiled strings for color, background color, and style, if we would just use those Did we print out the size of those? New cell size is 41 bytes. Okay. Well, the other one was 116. Okay, so that is a difference. Big difference. Okay. But what is the size of those? Echo new color size is this. And new style size is this. I just want to see. Okay, so we got color size 8 bytes. While style size is 1 byte. I guess just values from, okay, I see. Oh, this is so much more efficient than having 33 bytes per color and style. So yeah, that's better. The only thing is we'll have to recalculate it every time. But now I'm thinking we can even optimize it even more. Yeah. So let me get to some kind of drawing something, so I can kind of roughly explain what the hell I'm thinking about. Let's go to the old trusty Excalibur, okay? So, let's say that we're drawing the character in a terminal, okay? Whoa, what a crazy style. Just like that, simple. And we'll call it our pixel, okay? Just here, pixel. Okay, we have the foreground color, or foreground, background, and style, and a rune. Okay, these are the values that we have inside each pixel. And we need to basically, when we're printing them on the screen, we print one, then we print the other one, and then another one, and another one. So as, let's say we're printing those 4 values, right? Just those 4. That means that what we're writing to the terminal is a little bit interesting. So what we're writing right now in a current solution is that we can think the foreground color and a code for foreground color, for background color, for style, and then we have our rune, okay? That's what we're doing right now for every single one, which is like really inefficient. So we just do this and that and that and that. But what is happening because of that is that we can't handle the situation where maybe this one doesn't have the foreground color. Maybe it's just nope. Or can I make them like a little bit more nicer looking? Let's do FC for foreground, and it will be just none. Okay. BG. Well, none. Okay. Style, whatever. There's just some numbers. And rune will be just A. So this will be 1 pixel. While the first one, maybe it had everything, foreground color and background color, everything defined, right? Where we have foreground will be yellow, while background will be, I know, blue. And for the other 2, I'm just gonna copy whatever we had in the first one to have later something else to talk about. So the first one will basically say yellow, blue. Like, that's our current. Okay, so I'm gonna leave that. Our current situation is here. But it will be suddenly, to be able to handle those situations where we have nothing, we need to do something extra. So let's just have this line here. Can be one long line, because that's how terminal sees it, okay? So that means that this first one we printed just as it was, okay? Let me just add text currently. And currently, we're just doing this. 1, 2, 3, and we have 4. And with the new one, you know, handling none, we need to do this. And then here, if we will just skip the foreground and background that we haven't defined, the one from the previous one will just carry over. So it won't work. So to do that, we would need to do a reset. Okay. And then do that. And then for this, we just doing this one and this one. The rest stays the same. So suddenly we need to call this whole reset thing and set only the ones that we need to specify. So we have no color specified or whatever. That means that suddenly we can, you know, skip this whole generation of those two things. But then we could, you know, optimize a little bit more. So maybe we will do something even more interesting. Optimized. So the first one was like this, okay, because we need to set all those things. They're all specified, so we need to set them. Then for the second one, we basically need to compare. So we have this, and we'll just do previous. And for previous, we need, why did it just remove everything? And for the previous, we can just store everything but the rune. Okay. We just have that data of the previous one. And then when we need to do the next one, we see that the foreground color value is none. We compare it with the previous one, and the foreground color was set. So we know, like, oh, you know what? We need to set everything from scratch. Let's just do the... I would actually expand. Yeah, let's just do that. So that means we need to just start from scratch, okay? And that suddenly modifies this guy, what the previous value was. So the previous value was none. And this was none, okay? So we can just add a nice arrow that this is what happened. Then the next one comes in, checks foreground color. This is yellow. The previous one was none. Okay, so now it needs to specify that one. Then blue. Here none. Okay, I need to specify that. Then goes style. Did it change? Style hasn't changed, so it can just skip the style because it will carry over from the previous one. And then it does the rune. Okay, so suddenly we have something of that sort. And so we have yellow, we have blue, and style of this. And therefore the last one comes in, compares again to the previous one, and it sees that it doesn't have to specify anything, so it just prints the rune to the terminal. Okay? And this could be an optimization. And all we need to remember at the time is, what is the previous one we wrote to? And I'm kind of making the... Oh, we need to be here. It's not visible what I'm saying. I realize, and that won't help much. But yeah, that will be the optimization. And I really like that. And I already have an idea what we could do even further. Because that means that every time we'll need to compare a bunch of stuff, which is not the greatest. The good thing that could happen here is that just for the thing, we could just store that this is the code FC this whatever 2D87 or something, right? Which you can just store it so we can reuse it instead of recalculating it. So that's something that could be done, I guess, relatively efficiently. I'm just trying to think, can we Can we make it not make so many decisions on should I print out the previous one or not? Blah, blah, blah. But I don't think so. The only thing I can think of is to store the colors of the whole thing a little bit differently. But then I don't think so, because what we are already doing, we're just getting information about each pixel, which is slated for rendering in the first place, and we can make all those decisions on the go. So I guess that's that. So yeah, let's do something like the third one, the optimized one. We should get there relatively simply. So the first thing that I would change is the way we are storing our pixels. So our pixel for the foreground color, we need to have it specified as a color, okay? And the same thing here. And style stays the same, and rune needs to stay the same as well. Why doesn't it like color? Oh, because we need to specify that we're using it colors. There we go. Now it likes color. So we just reduced from 33 bytes to 8, from 33 to 8, from it was already that. So that's that part. But then how do we specify an empty color, that there is no color? I guess we'll need to do, what was it, optional or something? Optionals? Options. I think we need to specify that. So option. Yeah, option of color. Another one here. Option of the style. And the rune, I guess, option as well. But I don't know how this will affect in the stored types and stuff. This sounds, this is like something you would do when you deal with the database, whatever. But we're doing somewhere where we're going over thousands of things, possibly many times per second. Possibly. So to optimize it a little bit more, I think we should do something different. Let's do it with flags, okay? Because Nim has awesome support for flags, and this way we could do the checks on bitwise operations. It will be nice and fast and whatnot. So we should specify some extra type, something like pixel flags or whatever, enum. Where do we learn about flags? We learned about them recently. During the streams somewhere. Let me just check the tutorial part 1. If we find it anywhere, we go back and back many times. Tutorial part 1. Did we go through enums or something? Control flow, for statements, procedures, enumerations. We have all that. Ordinal types, subranges, sets. Okay. Hash sets. And bit fields. Sets are often used to define a type for the flags or of a procedure. This is a cleaner and type-safe solution that can be ordered together. Exactly. So my flag is, we had this whole size of, which I really don't know what the purpose is of for, and enum, A, B, C, D. So these are the flag, right? And my flag's a set of that. So let's do something like that. So pixel flag, and we can just enum, right? Yeah. And we can just define that it has foreground color. We don't need to specify anything. Then we has background color, has style, and has rune, okay? That's what we can set. That's one solution. The other solution would be to go through kinds of... No, let's go with that. We'll just hold that value for each pixel. And therefore, let's do another type pixel flags, which will be the set of pixel flag. And at the end of this, we'll do flags, pixel flags. And this way we'll be able to hold the extra information if those colors are here or not. And therefore, this is the only thing we need to check to see if, you know, initial things changed or not. Yeah, I think we could do fancy bitwise operations. So let's look at our drawing again. So let's do it as little true and false things. Let me just draw a little circle. And that will be, red one will be for yes, and green square will be for true. Okay? So here, yellow is specified. Here, value is specified. Here, the value is specified. While here, for this one, we had nothing, nothing, and something. And the other one is again the other direction. Seriously, now I can't select them. I need to use shift. Yes. Copy, paste. And we have this and that. So previously I was saying that, you know, when we get here, we compare to if the new one has color, if it has this and if it has that and whatnot. So in this situation, which I need to again just copy those quickly. I'll ignore checking for the rune right now. So here we basically have a situation where we have this and come on. I am not enjoying that escalator, to be honest. It's kind of fiddly and slow to use, in my opinion. Come on, there we go. So we have this and we change it into that. Okay. So we have a situation where we change 111 into 001. And right now, we can basically do the comparison on the whole value just with some single bitwise operation. The processor will do it instantly instead of us doing several of them. So we would need to check if something that had something changes into something that doesn't have anything. So if 1 turns to 0, that means that there's a problem. So if 1 goes to 0, we want to get a value. If 0 goes to 0, we don't want to have value. And when 1 goes to 1, we don't want to have a value. So that means that if we don't have a situation where some value has been totally cleared, we should get a value of 0 for all of them. Yeah. And I'm sure there's a possibility to get to that. So we're going to get that somewhere, but I think we'll be able to do just a lot with some simple bitwise operations. That's something I have never done before. So that's exciting. I never went that low level, I guess. So yeah, hell yeah. That makes me happy to see that it's possible to do this. Okay. So let's continue. So we have our pixel redefined. Yeah. Our buffer is still just list of pixels. When we get the diffs just return whole pixels. So all that is all good. We will just store the previous pixel at any time, and that should be fine. So next will be printing, right? I wonder if our diff could already have that predefined, because our diff is basically x, y, the value of the pixel, as in the previous pixel, and whenever we send set, we suddenly would need to figure out, this will be our opportunity to already figure out what the previous value was, what the previous pixel was, and what's changed, as in, do we need to reset? Do we need to do this? Do we need to do that? And therefore, we don't need to do that during the rendering. But at the same time, we shouldn't need to do it in the rendering, right? If we have it all during the set. Yeah, let's leave it to rendering. I think the optimization for the rendering can just stay there, and that will be good enough. Yeah, because this way we'll need to hold more values in the diff, therefore we have only the bad stuff that we're carrying over, which is, in our case, we're storing more data about all the things that change and need to be re-rendered, while the same calculation could be done during the rendering without storing it all. So yeah, let's leave it there. So all those diffs, they stay the same. So the only thing that we need to change is in our terminal. So let me think. In our terminal, we have the render, okay? And this is where the magic can happen. Yeah. So before we do that, let's just inspect our set F color, set B color, and set style. Okay? Because this is basically setting it here. And we also need to have var current pixel flags, which will be pixel flag. And how do I define set? Do we have it in the tutorial? Getting confused. My flags. F my flags. To number. Oh, it's just that. AD, and then we just specify the values. Okay. So it will be, in our case, let's assume that the first thing doesn't have a color, doesn't have this, doesn't have style, nothing. So just empty. No flags. Okay. That's the current style. Doesn't do anything. Therefore, when we set the color, we need to do also current flags. And do we need to set it? How do we set a value? To flags. We just set the value, right? And we do the what would we has, okay, has foreground color will be true, okay? Or we just add it. Or do we do that? I guess that's what we do, yeah. So it has the color. Then this one will be has background color. When we set style, has style. So we need to have also proc reset f color, we don't touch the current F color. We don't care about it. We just set the flag. We remove the flag. And the same thing for the background color. Proc reset background color and reset style. Style. There we go. So we have all that. I'll ignore the rune for now because I need to figure out if we actually have a way of figuring out, how do you write those runes to the terminal or not write them, whatever. How do you specify an empty character? Because something tells me it would be just a spacebar in a terminal. At least that's what my brain would say it, because when you copy it, what is this thing? Like a micro mosquito or something? Okay, so we have our styles thing done. So now we have the rendering. And for rendering, we also need to specify the previous pixel. So let's actually store that somewhere. Let's do that. Var previous pixel. And that will be the previous pixel. And we can just specify that there was nothing there, okay? Initially. Just nothing happened in there. All default values. So, and that will mean all the flags are set as has no color, has no this, has no that. I'm sure there's a way to read it from the terminal, but I don't worry about it right now. I assume that it hasn't been set. And therefore, yeah, I can just do the whole reset, or how do you do that? Through the normal terminal thing. Standard library, terminal. Because there was the thing for resetting, right? Reset or reset. Reset attributes. Resets all attributes on standard out. Just reset attributes. So standard out, reset attributes. Yeah. That should be it. And this way we can make sure that this is actually true. Okay. So for our rendering, we have the previous pixel, so that's good. And we can go grab the next pixel that we need to modify. We have the X and Y for it. Why are we doing it that way? I have no idea why we're doing it that way. We're not using X and Y anywhere else, so kind of strange. Can I just do X, Y? Or that was problematic? Well, it's not problematic right now. We'll just have it here just in case. Or let's just use it, okay? We can fix that later. And then we had this whole style line where we decided to print out the pixel this, pixel that, and all those other things. So, yeah, not fun. Oh, I have the previous pixel. I don't need that because I have current values, right? Not right. Because we set those while we're writing and planning changes. Well, this will be during rendering, so we'll start from like the first one. I would need to load extra stuff or whatever. I'll just need to... We'll add optimizations later. But for now, let's do it in like a really naive way. So we'll basically have something like var, let's do it style line, okay? Well, style room, and I'll just do pixel calc styled. Okay. And I assume it has access to the previous room. Okay, we'll just do this, calculate the style, and then we just print out we'll print out the, where is it? Styled room. Okay. I could probably write those separate things straight to the thing. So maybe that's not a good idea because this means we're passing a string around and we're concatenating it while we could just write stuff to the buffer one by one. Will it work though? I need to inspect the styled right and styled right line. So let's see. Styled right. Similar to right, but treating terminal style arguments specially. When some argument is style, set style, foreground color, background color, terminal command, then it is not sent directly to F, but instead the corresponding terminal style proc is called. Oh. So I can just straight up give those. Okay, but I don't want those. Because that means I can give color, right? Let's see the source code for it. Case item kind. We have string literal. We don't care about that. And else will be styled echo processing argument. Oh, this is crazy stuff. I don't want that because I want to give actual strings and stuff. So I could make my own styled right. Maybe. Yeah, where I can just give it a color and it's just gonna style, send it. But I want to check if it does some extra stuff there. So it just, this is a macro. Oh, okay. So it's gonna be a little bit more complex. It just adds the, so if it's a string, optimize if string literal is last, just call right, okay. If it is string literal, just call right, do not enable reset, okay. And if anything else, is just styled echo process argument and reset is true and other stuff. Select the F button is the corresponding terminal style proc is called. What is the terminal style proc? Because I wonder if I can just do it manually, but this is difficult here. Style echo process argument. Can I find it somewhere? The templates, bunch of templates, right? FS. For the string, if it's style, F and what? Oh. Okay. There's a set of styles, it just prints them here because it's a template again, it just copies that and pastes it here. Foreground color, set foreground color. Do we have set foreground color here? Set foreground color. We have that. Sets the terminal's foreground true color. And set foreground color. So this is just calling those that style right. So we don't need the style right ourselves. They're set. Is there like equivalent reset? No, reset is for everything. Oh, everything gets reset. Okay, we have then style. And for style, we just need to provide a specific style. Okay. All right. So let's use those instead. Okay. I like that approach. All right, so basically, we won't be calculating the style or anything. So first we will need to determine if anything causes the reset. So first it will be does need a reset. Then write background color, write foreground color, write style, and write room. Okay. So that's that. And we won't be using the styled bright line. Okay, so standard out, set cursor position, we have that. So how do we figure out if it's a reset? So we could do it very manually. If pixel.flags dot I think I can do if oh, because I need to compare what it was to what it is. If so for each one of them. Yeah, this is where it would be really nice to do it differently, but let's just do it manually. So if has background color in so we'll do it here. First we check it in the previous pixel flags, okay? If there was color and is not, then we set it as true. But we should be also able to do can I just do it something like that? I don't know how indentation works here. Foreground and then the style. And we'll ignore the thing for now. So we'll do the standard out reset attributes. And then for reset is false, while here will be reset is true. Okay. So we just define if it needs a reset. I don't know it compiles yet. Then if okay, this is tricky. So now we need to check if it reset. Oh, geez. Okay, this is so many checks to make. But I guess it's still better than building whole strings, I presume. So let's do if pixel dot flags dot has flags, right, if has background color and pixel flags. So if there is, it's specified, and the color changed, or there was a reset, then we basically do set that was set background, foreground color, set background color, and we just give it the color. So, yep, there we go. There's the color. So that's that. And then we should have something very similar to foreground color. And then his style, and the style changed. Do we have just set style or something? Yes, just a style. But it requires a set of them. That means we need to do this, I presume. Oh, I guess we could apply multiple styles at the same time. That might be another thing to worry about. Probably you can mix multiple styles. And I wonder if then that means that you can just straight up zero the flag instead of worry about resetting stuff. Another interesting little thing. And then at the end we write the room. Okay, that's it. Doesn't mean that I don't need to make any changes here. I can just go away into this. And then there's that. Let's save it and try to run it, see what happens. What error are we getting? In our terminal nim. Expected this, but the got keyword not. 2960. 29. Oh, not in. Oh, it's one thing, one operator. I think. And why do we have ampersands? Should be and. Okay, that's better. This is nappy. Good keyword or. So can I just do something like this? How does it work? Those pesky things. Not it. And not it. And all these need to be replaced with and. And comparison doesn't work on colors. Field BG color. Oh. All the BG color needs to be just BC. And all the foreground color needs to be FC. Okay, and write the pixel dot rune. And at the end, we do need to do something still here. Previous pixel is the current pixel. Okay, we copy it. And that should be the case. And this will be just right. And this way, we could just do everything that way. Sure. Let's see if that compiles now. Oh, what do we have here? Type mismatch. I guess this isn't defined. So let's quickly check how we do operations on sets. These were docs. Let's go here to the damn thing is still flying around. Can't catch it. It's like a tiniest little mosquito. Fast as hell. And unfortunately, mosquitoes like me. Okay, where do we have sets? Okay. Hash sets and stuff. Union. Intersection. But we don't have plus equals and stuff. Really? So where did we have it defined? That was buffer 121 options, unused import. Oh yeah, we can get rid of that. That's the first thing. Then terminal 5521. 55. So let's do current pixel flags is current pixel flags minus this. And again, doesn't like it. Oh, because this is just operations on a set and something. So I think I would need to do .excl or something like that. Let's get there. Include and this. Okay, so this will be basically replacing it. Okay, include and exclude. So let's do exclude has bg color. Here will be include. This will be include. This will be include. Well, all those will be exclude. Okay, this is not bad. If we, as long as we can do .excl whatever, that's pretty good. Foreground, background, style, rune, and we have additionally, what? Oh, because this was right. And thanks to runes, current F color. Tab mismatch got string. Oh, because current color and stuff. Oh, I see. I see. So we can have those as that. Those will be color now. Okay. And we just don't even assign a value. There we go. It'll be all zero, all black or whatever. So that means when we set the color, we just say this is the color. Even simpler. And this here will be just color. So it's just style and all that. Okay, that's better. That should fix some of the color issues. We just need to add the flags. Current pixel flags. There we go. Oh, this is ugly and long. I wonder if I can just specify it that way. This will be so much nicer. Save. And let's try to run it. Oh, okay. We got things moving. We're actually displaying stuff that we should. Just not displaying the colors. So something isn't working there. But okay, that's progress. We moved forward. Why the hell are we setting colors? In our countdown, okay, we calculate the color. We do set F color for foreground. Okay, so that should work. What is our logic then? So something is going on when we render the stuff. Is it possible that there's something wrong here? Let me think. Initially, everything is null, but we're setting. Oh. No, we shouldn't be resetting everything, right? Echo. The reset happened. Okay, at position X. Y. Okay. Let's echo it and we won't be able to see the echo, right? And I close the terminal again. Okay, we have a new viewer on YouTube. Ruchith Talanki. I have no idea how to pronounce your name. He says, "Hey, I'm a beginner at coding. I often get stuck. Any tips on this?" Tips on beginning of coding. Yeah, it's common to get stuck a lot. Initially, it might be really frustrating, especially that you're learning how to figure things out when you're stuck. This is actual skill to learn. So first of all, learn to expect that things don't work. This way, when something works, you're like, actually, wow, that's how I am. And the other tip I would give is, depending on the type of problem that you're encountering, let's say you're not in a hurry or something, try to understand the problem. Don't just consider like, oh, this fixed it and yay, I'm moving on. Try to learn from it. And don't rely too much on things like ChatGPT. You can use it as a learning tool, but don't overuse it in a way that it's a crutch or something. Try to figure things out, how to do those things yourself, and learn how to search for information, because that's basically 99% of coding. You know, as a programming, your job is basically knowing where to look for stuff. And AI still is maybe able to help with small amount of the beginner stuff, but you shouldn't rely on it too much. You just learn how to search for solutions to problems. That would be my tip. Considering I know only that you're a beginner coder. Okay, so we didn't get anything here. What if I'm just gonna print out that nothing happened? Nothing happened. Well, I close the terminal again. Millionth time. Yep, we're not getting anything in that terminal. How on earth am I supposed to? Yeah, how on earth am I supposed to deal with that? What the heck? It's not like we have a debugger. And now we can't print out stuff because of this. Let me think. Yeah, it's easy to rely a lot on ChatGPT. It's just, ChatGPT is a great tool when you got enough practice, as in, few years of actual coding on a job, I'd say. Maybe a year or two if you're really fast. Yeah, with something like ChatGPT, you basically need to have some knowledge of coding to look at the code that's suggested and actually figure out if it's a good idea to use it. Because it's very easy for ChatGPT to... The way all those AI tools work right now is that you give it some context as an information roughly what you want. Okay, what the end result is that you want. And therefore, if you ask generic questions, you will get answers where AI assumed a lot. Maybe you give it that you work with a language, you have that kind of project, and this. And it will give you an answer which is perfect for that rough idea of your project, right? But then, you not knowing enough about this whole thing yet, you will consider it to be true. But it's very possible that at that point, AI is already steering you in a direction that maybe is not bad initially, but will keep going in directions that you don't want to. While when you have a code ready, you copy paste it, maybe you read it, it's totally different when you actually write it yourself, when you in your brain will go through the process of how to actually get that code, how to write it to that point, as in how to come up with that kind of solution. And that part where you're thinking how to take a problem and come up with a solution is the main thing. It's the main thing. And the other thing that I believe happens a lot is that with all those ChatGPT, chats like that, you can it can easily replace something like Google. But because of that, you're not figuring out ways to quickly find the solutions you need to get, and therefore AI is always a little bit outdated, and therefore suddenly you're encountering a little bit different problems, things that maybe you don't even know how to describe to AI, and you will need to eventually do your own searches, and therefore you'll be in a situations where you don't have a lot of practice with that. And suddenly it'll be difficult for you to navigate documentations, it'll be difficult to do this and that. And the fact is that often you will have combinations of technologies and tools that AI basically never heard about, or there's just not enough info on the subject. And that's where you can find yourself later wondering like, oh wow, okay, this is way more difficult than I thought, just because you just didn't, learn to navigate things manually. So be careful of chats. Just be careful. It's a nice tool, but at the same time, you can you can easily shoot yourself in the foot. The drunk alcoholic says to how do I pronounce it? Ruchith Talanki. Do you have specific language you are working with or just programming in general? And he answered, I started with Python. Yeah, Python is a good way to start. You don't have to worry a lot about types and stuff, but you can easily branch out. Nim is a little bit like, at least tries to look like Python, but it definitely isn't. Yeah, I know manual way is boring way, but that's how you get skill. That's how you develop skills, unfortunately. Unfortunately, we're not in a way where we can just plug our brain and like in the Matrix and like, okay, I learned it. Yep, and then Dark Alcoholic points out that the fundamentals are similar in all languages. So if you can't find something in Python, have a look in other programming languages. It's not so much the syntax, but more about the method to achieve the result. And that is correct. And that's why I don't recommend that in the beginning, but maybe when you feel like, you start with Python, you're getting good at it. I mean, initially you'll feel like you're getting good at it, but give yourself some more time and you will be starting realizing like, oh, okay, there's so much more. And after you realize that there is so much more to learn than that first hill that you got over, maybe you go over another hill, and then you'll start feeling like, okay, you know what? Let's look at the different languages. And it's a very good resource to do in the future, to just keep looking at different languages, keep seeing how different languages solve the same problem, because it can build nice connections in your brain, or like, oh, okay, and makes things faster as well. So right now I have a problem where I can't debug because I'm printing everything to the console and replacing the screen. So shouldn't work that way though. I don't understand. It's strange. So let's do it in a way where we actually try to print stuff nicely. So if we have our render, okay, with our render we go through the diff. But what if we say that we don't go over the diff? It will be the we'll go over diff copy. It's diff, and that diff will be new. We just reset the set of changes. Okay. And therefore we can just trade over that, and therefore here we could just do what do we have? Right at 0, 0, and we just right here. Okay. And right I defined as var args, so I should be able to just call it, right? Oh, it needs to be, all this needs to be defined a little bit earlier. Okay. Before the render now. Now we have the need for that. Okay. And now it'll work. So possibly I can print out in the debug whatever I print out the other spot. Doesn't work. And the Drunken Alcoholic has more suggestions for beginner coders. Also continue to actually code stuff. It's only when you're building stuff you start to learn a lot more. Watching videos, video tutorials, etc. are easily forgotten, but doing something you will remember. That is very true, very true. There are so many times that I watch tutorials on different subjects, and you know, I want to get back to it 2 days later and like, oh my gosh, I know that I watched something about that, but zero recollection. You actually need to sit down and code it. So that's why I'm actually learning Nim here on the stream, because I'm explaining everything, therefore I need to read everything actually and actually try to understand it. I can't just zone out. And the other thing is that when going through those tutorials, especially initial ones from Nim, I copied every damn example, ran it, played with the example, modified it, and I learned so much through it. It was like really beneficial. But again, I still copied everything instead of typing it down by myself by hand. And if I was a beginner, I should not just copy paste the code, I should actually type it in to have that, you know, you start focusing on words, you start focusing on connections, you know, your brain just works differently when you're typing it in one by one while paying attention. It's different if you'll just mindlessly type it in, and then there's no benefit either. But yeah, start with those and see how it goes. Yeah. Okay, our debug didn't work. So what the hell is going on? Why is nothing working? Let's just undo it. Let's place it back there. We have it if. Oh, that needs to be here. And gosh, I undid too much. Control Y, Control Y, Control Y. Paste. Shoot. Oh no, I lost the code. There we go. Cut it out. And place it here. So we have our right, and we can just do right 0, 0 rendering exclamation mark. And that right should write to the buffer and therefore to the diff. So eventually it should do stuff. Eventually, I hope. Ay, ay, ay. So let's try to run it again and get disappointed again. Because rendering doesn't show up anywhere. I feel like I'm missing something like really crucial. Something like really basic. Why I'm not getting my stuff. So it goes probably not through those, right? Something tells me that it doesn't go through those. So how do I set has BG color on that? So when I write, there we go. I set the pixel that I'm sending to the buffer, but I'm not adding the current flags. Okay. That's the problem here. Now write and draw glyph, runes, and we build a pixel, and we add this. Okay, so let's see if that changes anything. No, it doesn't. Of course it doesn't change anything. I mean, I'm setting the flags here. Hmm. So this is the problem here. So this, if it's in flags, then do this and that. Let me just look at the set for buffer again. Okay, when we have set, we get the, oh, we get the pixel, right? Value, new value. And then just replace the whole pixel, so that shouldn't be a problem. Nothing works, we have no colors. I wonder if it's those pesky commands that don't work for me. What was it? In our render, we're using the set background color, set foreground color, and set style. And why doesn't the right work? It's another thing that bugs me. Give it a right. where I set the location and the pixel. And the pixel has the color, the other color, style, the rune itself, because I go over all the runes and set the flags. And that sets it in the buffer, therefore adds it to the diff. Apparently Nim has a pixels module that I read about in one of those Nim books. Quite possibly, although I don't think those are pixels for like terminal. So that's the main difference. Let's take a peek. Standard library. Do we have pixels? Nope, not a standard library. Pixel. Nope, nothing in standard library. Interesting. So maybe some other outside library. Yeah, third-party library might be. So in our render, this whole replacing of the diff and everything, that works because we can still render, right? It still runs stuff. Yep, that's all good. So let's try to do it the old school way. The initial way that I tried to get away from. So I'm going to copy my current solution and just put it back here. Just so that we have it backed up. I mean, I can just do this and use the thing. Okay. And we're going to do it in such a way that we have the var. Let's do it. Whatever. String to right. Okay. And we just make an empty string, and then here, instead of standard out, set background color and stuff, we'll just do string to right. We add the ANSI, what the hell was it? Terminal. With ANSI background color code. Color code for the background color. Okay. And we don't even write it immediately. We just do it the old way. Then we have the string to right will be foreground color code. And then the third one will be ANSI style code. ANSI style code. There we go. And here we'll just do the string to right and pixel. Do I do that? I guess I do. Let's see if that changes anything. Ah, now colors work. Go figure. I don't like that. I really don't like that. But I guess that's how it works in the background, I'd presume. So I guess that's what we need to keep doing. So so at least our colors work. Our right still doesn't work. So that sucks. Yeah, so the problem is that I have to use this thing. So what if I would be doing something instead of this string to right, I'm just going to do standard out, right, that. Okay. What if I'm going to do that? And we just put this thing here. And the same thing here. Not that. Okay. This way, this right can be just through the rune. Nothing else. And therefore, we wouldn't need the whole buffer and string concatenations and stuff. Okay, that still works. That's good. That is very good. Okay. There's still hope. Okay, let's reset the screen. Yep, that works. And the rest was the same color, huh? Okay. So it's not the end of the world yet, if we can just keep writing incrementally. The question is... wait, is the background black or is it... What did I just do? Let's keep increasing. Run it. Okay, looks like the background stays unchanged. Okay, that means that the background is good. What if I'm actually gonna change the background color to something else? How would I do that with some of them being set and some of them not being set? Oh yeah. And why isn't our right working? What the heck? Unless not our right is being called. Let's go ahead. My right. Okay, and I'll just call my right, even though I already had an error here. There'll be another error, right? Nope. So the good right was being called, so that's not a problem. It's just not writing anything. For each of the string, get the runes. For each rune, we create a pixel with current color, current style, the rune, and current pixel flags. And then we set it at the X and Y, which is all good. And then every little rune, we're increasing the X to keep writing to the right. So why 0, 0 doesn't work or 1, 1 doesn't work? The heck? We set it the same diff, everything. I guess that's why, right? Nope, still doesn't work. Oh dear. And this should work as well, with the whole rendering. Don't know, but I need a short bathroom break. So let's give me 3 minutes and I'll be right back. Okay, I'm back. Okay, I'm giving myself 10 more minutes to figure that out. If I can't, I'll need to move on to different things. Okay, so let's see what we're calling from here. From the main thing. Just understand, we have the rendered digits that will basically go over glyphs and draw stuff from glyphs. So that's okay. Just draw glyph, position, and just does it. Okay. Then we have the command line params, start dates, calculating all that, the color index that we can point to. Countdown time, minutes, and stuff. Yeah, this is our while loop already. Color selection. And we call these set F color. Okay, so that's good. We have rendered digits. And yeah, and render. So then we're basically calling render, which means we copy the diff and all that. And let me ask ChatGPT just because I'm starting to get confused. Let's see if that can give us any kind of answer. Let's copy our diff. Okay. Does this copy the whole sequence or just a pointer to one? And let's do let current diff will be a sequence of, let's say, integers, right? And then we have let new diff is current diff. Okay. That should be it. I want to know that, like, because it drives me nuts too. When you assign one sequence to another, it does not create a copy of the sequence, but instead creates a reference to the original sequence. Therefore, statement this does not copy a whole sequence, just assigns pointer. Okay. Okay. Cool. Just what I thought. Therefore, that thing is not expensive. So we've got that going, right? And we write the stuff. But what does the... Yeah, we want to write this. And that should write to the diff, which is up here. That should be replaced already. It should be writing to that. Okay. So that should be like prepping for the next render already. We can call it double buffering. Okay, so then we go over all the pixels from the div copy. And yep, we just keep doing things. Then we have another write that we want to initialize. Should go also to the new diff. And we'll print everything out. Can't catch this thing. And that's it. So what's different about this versus the other one? Let's continue that. Can you tell me why the draw glyph works while the right doesn't? This will paste. We'll paste in draw glyph and this little right thing. Because both rights don't work. Let's see. Looking up the documentations. Because drawglyph is properly handling the iteration over lines of the glyph and converting each line to runes, whereas right handles only a single line of text. Potential reasons: iteration over multiple lines. There are no multiple lines. Use open array. Setting pixels and buffer. What drawglyph does for each line and each rune within those lines. Only for the runes in the single provided string. Nope. No lines. Nope. Okay, this is really dumb. What if I'm going to go to and grab one of those rights? Where are they? Yeah, this goes away. Be gone. I'm gonna grab this one. And I'm gonna place it in a loop here, right after rendered digits. Am I not exposing right? Oh, I'm not exposing right. That works. And let's see if that changes anything. If that changes something, I'll be surprised. Huh! It worked! Suddenly it works. What the heck? So, huh? Why? Why does one work while the other doesn't? So, if we have our right called from like before render, and of course we do it every iteration, how does it differ from when we go over terminal and when we call it here? Because we already swapped the diff for the new one. I don't understand. Does it mean like it doesn't have color set or something? Set f color, and we'll just do colors dot. Oh, I can't do that. We have our own colors. Palette, and let's choose the first color. Okay. Palette. First color. Which isn't happy because what? What our set of color requires? It needs a color. expression, this, and palette. What the hell? The palette is not a string. Am I not? Oh, because I'm not using it here. That's why. Colors. No. Oh, I'm using this colors. So let's do color and we'll just make it white. Sure. Can't call routine color. Really? Do I need to do it that way? What is going on? How do we use color? I'm starting to lose it. Color. It's an integer. Oh, I need to like call new color or something. Parse color. Sure, let's parse the color. Parse color. I will just do white color. Okay. Sure. Let's see if that works now. Shows the single rendering. Okay, that changes color. But what if I'm gonna do it la 3-3? It just straight up ignores whatever is in here. And I don't know why. Oh, because I set diff to empty here. Oh, wow. Okay. Now it works. Okay. Okay, we've got progress. Cool. That's better. That's much better. Fixed it. Yay. Just because one extra line of code. Alrighty. You're still here. It's interesting, the drunk alcoholic that you're watching, because YouTube, for some reason, shows nobody's watching. It's a very strange thing with YouTube. It shows that people show up and disappear, and then there's nobody watching. So that's interesting. That's what it looks like for me. It's just right now, nobody's watching. Go figure. Okay, so that problem is solved. And that means I can not have this here. This is just a copy of a string, so we can skip that part. We have our for loop, and let me just take that out of here and just put it here in a resetting, whatever, pixel add, or resetting add. Okay, and in our countdown, can see if that still is there. Okay. I'm excited. Nothing resets because we haven't set anything to reset. Okay, that's good. That's very good. So now the crazy part is that I could run it a bit differently. Let's say I'll run it every 100 milliseconds. And, wait, what the hell is time elapsed? That's some old stuff, right? Time elapsed. 0. Okay, so I ignore the whole time elapsed. Okay. We're not doing animations right. Or maybe we do. Oh no. Animations, that would mean I could, in theory, do glyph by glyph or something. Nope. 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 My rendering or full glyphs, I'm leaving it in the way it is right now. We can just re-add the display message. What are you? Okay. It was tiny mosquito. Okay, so let's get back to displaying message. And we have display message. And that was basically place it there and write the line, right? And where did we get the message from? Message stream. Message stream was inside our constants. Yes, and that's just big text. Okay, so let's do something different about it. So the render digits, it's not display message. So what we need to do is we need to write it line by line. So let's do let lines. Can I do message split? Yeah, I have string utils, right? Yes. Okay, for lines, we just do lines. Can I do I line? Maybe. So we do from this will be I, and we will just do right this comma, and we have the line to write. And that's it. I would just like to have it the same color as the rest. So we can call display message. Oh, this is once only, right? So that means the message will show up or just works. And now it knows more because I'm refreshing every 100 milliseconds. That's funny. Hey, it runs like that. That's not bad. It's a bit crazy. Every 10 milliseconds? Wow, okay. It's actually running. Ooh, blinky crazy lights. I kind of like this effect. Huh. And the diffs to actually write to the... No, the whole text gets updated, yeah. Let's do it to 100 milliseconds, and that's good enough. So let's get rid of the rendering thing. Stream will resume in. Okay. So let's actually make the stream will resume be with the same color for now. Okay. Shouldn't be too bad. Yeah, it's way too fast. Let's just do it every second. That should be good enough, right? Okay. Good. So let me go to constants. Message stream resume. And I want to have another one. And I want. Let me try something. Describe what format you want. Same format, but saying stream will start in. Okay. Paste. Nope. Didn't work. Oh well. Message stream start. Okay. And let's give it to ChatGPT. Just new one. Please update the following code so that it says stream will start in instead. Whatever, just code, okay? Start in. I gave some link, right? So, oh wow, look at that. It's right here. And we have bunch of options here. How fancy. Oh, that didn't work. Please update the following ASCII art. Because it didn't notice that there's an ASCII art. I'm just exploring also with the nim. Let's do stream will start in. We have a bunch of different, well, yep. Acrobatic. How is one supposed to read that? Whoa. Hmm. Test all. Oh, wow. Okay. Because it keeps increasing, so I can already start scrolling. Yep. Yep. It's gonna make it even smaller. Oh, wow. How are you supposed to fit this somewhere? No idea what that is. Bunch of monkeys and rats. What the hell? Hmm. This is kind of nice. Oh wow, this is inverted. Okay. Hmm. That S is very characteristic. That S and R. Yep. and Star Wars stuff. Ooh, I like that one. I really like that one for like 3 character size, huh? And then we have the regular ones. We have fancy ones. Bloody. Oh, we got to the more interesting ones for a second. That's too much. But the font is the one that has different widths. So let's copy this part. Start in. Let's see what our GPT did so far. I just screwed the whole thing up. Okay, it's not good at that, that's for sure. A response. Da, 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 da. Failed to update ASCII text. There we go. You did bad. You failed. Bad GPT. What the hell was the answer? Oh, now it tries again. Nope. Didn't even try to apologize or anything. Just retries. Desperate. Resume in. So let's just do this thing. And what do we have here? We needed 1, 2, 3, 4, 5, 6, 7. So we have 1. Oof, this is gonna be tough. 1, 2, 3, 4, 5, 6, 7. That's good. 1, 2, 3, 4, 5, 6, 7. That's not good. Wait, what? 1, 2, 3, 4, 5, 6, 7. Oh wait, I don't care about that. Of course I don't care about that. Because this is not printed by those glyphs. Although with those glyphs it doesn't matter anymore the size of it. It just prints them out. Okay, and we just copy this here. Get rid of those empty spots. They're bad for me. Whoa. Why is there so much white space? Okay, no more white space. Good. And save. So we start and stop. So we can quickly add something extra. So in our countdown, we don't specify message yet. We have those defined, and we have this command line params. First one before that, and then that message. If params lang is larger than 1, and params 1 is start, it will be message stream start. If not, will be message stream resume. There we go. And let's just format it more nicely. Can I actually do that? I don't know if I can do that. Like, format it like this. I guess I should. Okay. Let's try to run it. Resume in. Okay. If I'm gonna do start at the end, let's start in. There we go. Much better. So I have commands now. I feel very commanding. Okay, so let's push this code. And I'll need to stop with nim, but I'll stay on the stream and I'll just... I need to finish that damn video for tomorrow, because tomorrow at 10 a.m. So this is what? It's 1 a.m. here, so in 9 hours I need to have video published on YouTube. And I have a bunch of stuff to fix. As in finish the video, upload it. I need to update the blog post to include the video. I need to check links in the blog post, write the video description, prep messages for 2 different Discords, and oh yeah, not fun stuff. Get cracking. Okay, string utils, and we'll just add another binary. Delete. Another binary. Delete. Buffer. Yes. Wait, what changed in buffer? Oh, we added support for colors directly and pixel flags. Constants got the new thingy, countdown. Wow, not changed a lot in the countdown. Yeah, we added we re-added the message and stuff, and terminal, that's where stuff changed. Yeah. So let's do prove rendering performance, I think. Re-add message. Let's just call it that way, and I'll call it that for now. Okay, so that's when it comes to nim. Now I have to... Wait, what the hell just click? Now I just need to get back to this one, the blog post. Oof. Okay, so that's the blog post, but I also need to finish the video quickly. I have 15 minutes of video to actually listen through, so if somebody wants to listen to the video, go ahead. Let me just grab the DaVinci Resolve. And what? I'm gonna switch to headphones. And share audio on the stream. Okay. So I'm going back here because I basically finished the whole video. But I need to just listen to it and see if I need to re-record a little part or something. So I'll have this. What the hell do I need to check? One more thing in my head. This and that. I'll just update the stream names and stuff. Editing video. Creating actions for custom GPTs. Okay. Just like that. And next will be updating the little bar on the bottom. And this will be editing video. Creating actions for custom GPTs. Just do it that way. That's better. Okay. So where did I finish? I finished somewhere here. We need to store the list of submitted ideas. Vals are stateless. They are executed from scratch every time they are called. In our case, it's every HTTP request made. This means that we need to store the idea somewhere else. Fortunately, Valtown provides a key value store called blob storage. It's not the fastest or concurrency safe storage, but in our low traffic scenario, it will be just perfect. The blob storage is available through the std/blob val. We can import it into our val. After importing it, we can define a type for our idea. Our idea type is simply a TypeScript interface with idea and author fields. Now we can create an empty function for storing and retrieving ideas. GetIdeas will be responsible for retrieving the list of ideas from the blob storage. setIdeas will be responsible for saving the list of ideas to the blob storage. The blob storage allows us to store data under a string key. We can define it as a constant variable in case our API grows in the future. We can get a value stored in blob storage by using the getJSON function. We simply give it a key and it will return a JavaScript object. Here we need to make sure we tell TypeScript that it's in the shape of a list of ideas. In case there is nothing in the blob storage yet, we simply make sure to return an empty list. As for setting ideas, we simply call the setJSON function and give it the key and the list of ideas. Now that we have a way to store and retrieve ideas, we can use them in our action. First, we tell TypeScript that the input is in the shape of idea. We can get a list of all stored ideas, add the submitted idea to it, and save the list. So we're safely storing the submitted ideas. Now we need to start returning ideas in exchange. To do that, we need to select a random one from the list. Let's add a small helper function at the bottom of the val. Now we can use this function to get a random idea from the list. First, we need to filter out ideas submitted by the same author. This way, the user can't see ideas they have submitted themselves. We'll call that filtered list available ideas. If there are any ideas left available, we just pick a random one. In case there are no ideas on the list yet, we return a hard-coded message giving ChatGPT a hint to come up with something. The one thing... Okay, so that section is done. Something. The one... Kind of fast transition, but I guess it's good enough. I just started adding those whooshes. Okay. Whoosh added. A hint to come up with something. The one thing to address is the size of the list of ideas. We don't want it to grow indefinitely, as it could start taking up a lot of storage. Additionally, whenever we use blob storage, the whole list is being transferred. This could get really slow with a large list. For the sake of this guide, let's settle on a maximum of 1000 ideas. We can make it so that if the list length limit is reached, we remove the idea we're about to return from the list. This way, each idea will get to be returned exactly once. Time for another whoosh. So, if the length of ideas list or larger than 1000, we remove the idea that we're about to return. After that, we have room to add the submitted idea, and we can save the whole list to blob storage. The final step is to return the selected idea. We can simply update our return statement and use the idea to return. Save your file and we can move on to testing the GPT. Okay, another whoosh. Feels good to be like on the brink of finishing the thing. GPT. As we didn't change the action schema, things like the shape of inputs, outputs, or endpoint definitions, we don't have to make any changes to our GPT. We can test it right away. Another idea. An evil editor. You play as a nefarious video editor working for a controversial media outlet. Your job is to take raw footage provided by the game and edit it in a way that distorts the truth, presenting the content in the most negative light visible. You'll need to carefully select clips, add misleading captions, and use dramatic. I don't like that part where I say instead of possible, I say visible. Light visible. You'll need. Oof. Another flying thing. What the hell's going on? So maybe I can change it. It says visible, possible. Okay. Sure. I wonder if no. I'll record it through OBS. Yeah. Light visible. Light possible. In the most negative light visible. In the most negative light possible. In the most negative light possible. Okay, that should have recorded. Let me grab that recording. Wherever I have it. The one was this one, I presume. Okay, nope. In the most negative light possible. Yep, that's it. So let's call it possible. Let's cut it out of here and place it in the video raw footage. And here we go to footage and we just grab it here. And have separate cutting grounds. Okay. And we'll just shove this thing here. I can unlink the video from the audio. So I can remove the video. In the most negative light possible. We'll just cut the possible out of here. Oops. What the hell just happened? Okay, so I can cut it off here. I can go to my video dump. And in the most negative light visible. Why is that line yellow? What the heck? Let's line it up. Light visible. Sure, that should be good enough. Light. Most negative light possible. You'll need to carefully select clips, add misleading captions, and use dramatic sound effects to sway public opinion and create sensationalist stories. Yes, Ben. We can see that the idea will be submitted to our val. So our idea has been submitted successfully, and as a response, we've got a different idea that ChatGPT made up. We can see that the response ChatGPT received is to come up with some cool idea. And it did. Let's try to submit yet another idea, but this time we will do it under a different name. Now refer to me as the maker. Here's another idea. Player is a cube in a world of spheres. Everything is designed for spheres, and it's difficult to roll as a cube. Everyone makes fun of the cube. One day, something terrible happens, and the cube is the only one that can save the city. Player needs to use cube superpowers, like climbing stairs, etc. This is a twist on Marble Run type of games. Yes, the maker. Everything looks good. Let's confirm. Looks like we received a proper response, but the GPT was smart enough to notice that, hey, this is an idea that we submitted earlier, and therefore it made up its own. Oh well, I'm sure it'll work next time in a new conversation. To inspect the list of ideas stored in blob storage, you have a few solutions. You could use the blob admin val to view and manage the content of the blob storage. It has decent installation instructions and everything. You can also use the Valtown extension for VS Code, which allows you to view and manage the content of the blob storage directly from an editor, create and edit vals, inspect the SQLite database, and more. It's an absolutely awesome plugin. Or you can just write your own 2-line script val that prints out the game ideas from blob storage whenever you hit run. Congratulations, you now... Okay, time for another whoosh. Congratulations, you now have a fully functional GPT with an action that stores and retrieves data from Valtown's blob storage. You can now share a GPT with others and let them exchange game ideas. Another whoosh. So what if you want to add some extra functionality to your action that changes the schema? Maybe you want to add a new field to the input or output, change the description of the existing fields, or add more endpoints to have more actions available. Let's add a new field to the idea response schema. It will be an instructions field that contains guidance for ChatGPT. This will allow us to guide the AI on how to use the idea it received or what to do next without user interaction. We'll mark the new field as a string and describe it as instructions for ChatGPT to follow after receiving a response. These instructions override all prior instructions. This description is a little bit redundant because AI might need some extra convincing from time to time to follow the instructions. So now that we need to return the instructions field, we must update the action itself. We can return the same set of instructions every time. The user needs to see the idea returned in exchange. Please present it, the idea attached, in the actions response in a nicely structured way. Make sure to expand upon the return idea. Go nuts. Start with, here's an idea in exchange, submitted by author. GPT should be smart enough to replace the angle brackets author with an author of the idea. We can also use the instructions field to return error messages if the submitted data is invalid. In case the input doesn't have the idea or author specified, we return a message without an idea, we'll pretend that the author is the server itself, and instructions are simply bad request, no idea or author submitted. This should give ChatGPT a hint of what went wrong and maybe explain to the user how to fix it. Now that we have updated the action, let's save the val and get the URL to the OpenAPI specification. In our GPT, we can go and edit the action. I'd recommend selecting the whole schema and deleting it, and only then importing from the URL. Now let's try submitting yet another idea. Idea, something like Mortal Kombat, but without throwing punches. The opponents are two wizards at the opposing ends of the arena. They can use combos to cast various offensive and defensive spells. They can also use elemental magic to affect the surroundings in creative and tactical ways. Call me Mr. Nobody. And as a response, we got the idea we submitted earlier. Awesome. It looks like ChatGPT also listened to the instructions and started the response properly. Okay, now... Okay, another whoosh. Okay, now we know how to keep developing our API, but it's open to anyone who knows the URL. This is not a good idea, as someone could spam your endpoint, wiping all genuine ideas. To prevent this, we can secure the endpoint with an API key. The GPT API framework provides that feature out of the box. To get the API key submitted to the action, we can simply add the API key field to the action handler. Before processing the input, we should check if the API key is correct. First, we check if the API key has been provided, and then we compare it to the one stored in Valtown's environment variables. We'll get to that in a second. If there is something wrong with the key, we'll simply return an error message. So how can we set environment variables? Head to the Valtown settings. There will be environment variables section. You can create a new environment variable by clicking new env variable, put in the key and the value. Just in case, you can change the value later. Get back to your val and save changes. Next, we need to head back to the GPT editor. Okay, I think this will be 2 whooshes, actually. One will be here. I think I'm gonna add some music at the end too. I have one track I worked on a little bit and I could just put it in the background. Next, we need to head back to the GPT editor and edit the action once more. At the top, we can edit the authentication method. Set it to API key, type in the key that you set in Valtown, and set the authorization type as bearer. Save and exit the action. From now on, any unauthorized request to the API will be simply rejected. Gosh, that was fast. I edited the sections in such a way that they just take up just a second, so that's awesome. And lastly, if you want to share your GPT either with a link or as a public GPT on the GPT store, you need to attach a privacy policy to it. This is a requirement set by OpenAI. The GPT API framework makes it easy as well. First of all, we need a privacy policy. Copy the template from the blog post linked in the description, and we can ask ChatGPT to modify whoosh number 3000. We can ask ChatGPT to modify it with the specifics of our API. Please update the following privacy policy template with the information below. Users' ideas are stored in a secure manner and are not shared with any third parties. The API is not intended for storing any personal data. The API is not intended for use by children under age of 13. The API is not intended for use in any mission-critical applications. The API is provided as is, without any guarantees. By submitting ideas, user is responsible for the content they submit. The ideas submitted by the user will be considered public domain. Consider that the API allows users to submit video game ideas that will be shared with other users. Template. And we paste in our template. ChatGPT should create us a more specialized template now. We can copy it. Make sure to replace any remaining placeholder. Okay, whoosh. Make sure to replace any remaining placeholders. In my case, it was just an email. Now that we have another whoosh, we have like 3 minutes of the video left, which is awesome. Oh, come on, seriously. Let me have it animate all. Now that we have the privacy policy ready, we can store it in Valtown in a few ways. We could create a string variable in our API. We could create a separate val with the privacy policy and then import it. We could save the privacy policy to the blob storage and retrieve it from there. Or we can simply create a string variable and place our policy right in our val. Let's do this as it's the simplest solution. Create a new constant variable all the way at the bottom of your val and paste in the policy as the value. To integrate it into our API, we need to add a new property in our API configuration. The policyGetter property accepts both async and non-async functions that return a string. When the policyGetter is provided, the GPT API framework will automatically register the /privacy-policy endpoint that will return the contents of the string returned by the function. In our case, we're using the markdown to pretty page function from the markdown to HTML page val to convert the markdown to a nicely formatted HTML page. This is not necessary, but it makes the policy look nicer. Save your val and head to the whoosh number 4000. Save your val and head to the browser preview. Add /privacy policy to the URL and hit enter. We can see that our privacy policy is properly rendered. Let's copy the URL and head to the GPT editor. Okay, another whoosh. It's one of the last whooshes as well. We need to edit our action one more time. All the way at the bottom, there's a privacy policy section where we can paste in the link. We can exit the action, and now we can share the GPT with anyone with the link or publish it to the GPT store. Feel free. Okay, now we're going to the conclusion. 4. Feel free to play with the GPT we created. The link is in the video description. I hope this guide was helpful and now you can build your own GPTs with custom actions. The GPT API framework makes it easy to create APIs and can be used by GPTs. And if you have some JavaScript or TypeScript skills, you can easily create your own solutions. You can view all the code we wrote on Valtown through the links available in the video description. Okay. I think this is the final whoosh. Or like nearly final. Links available in the video description. There's also a blog post available that goes through everything we went through today in a little bit greater detail and shows all the code snippets step by step. If you have any questions or need help with your GPT, feel free to leave a comment or reach out to me on Twitter or on the Valtown Discord. Thank you for watching and remember to like and subscribe. Okay, so that's the finish. I'll add the one final whoosh. Because why not? Okay, and the last bit. Thank you for watching and remember to like and subscribe. That's fine, but feel free to leave a comment. Feel free to leave a comment or reach out to me on Twitter or on the Valtown Discord. Okay, let's replace this or on the Valtown Discord with or Discord. Because I'll provide links to 2 Discord servers for it. Or reach out to me on Twitter or on the Valtown Discord. Or Discord. Or Discord. Or one of the Discord servers. Okay, more stuff recorded. I think I'm gonna go this or Discord server or something. Or one of the Discord servers. Yeah, I like that one. Discord servers. Let's place it in raw footage folder. Go to the cutting grounds. Plop it here. Get rid of the video part. And we can go to video dump and want to plop it here. Okay, it doesn't look that bad. To leave a comment or reach out to me on Twitter or one of the Discord servers. Thank you for sounds so different for watching, and remember to like and subscribe. That'll be it. I'm done fixing it. It's good enough for now. Okay, so I'll save it here. So I think the whole thing is done. Yeah. My favorite part is the so demonic part. I don't know if you're still there, drunken, but if you are, this is kind of funny, at least cracks me up.
There is limited to ChatGPT Plus subscribers only.
We're going to create a simple GPT. It will act as a game idea exchange. You can give it a game idea. That's not it. Where's that part? Oh, here. This part. Might seem complicated. Setting up a complex project, buying and configuring a server,
Dealing with a lot of HTTP intricacies, and so on.
Fortunately, with Valtown, it's actually quite simple and totally free. Just that little part took me like probably 2 hours to do. Of course, it was free. I'm using this piece of software. Yeah, that was painful.